Hello everyone, this is How I Love Geometry. I'm Mr. Chang. This problem is from 2018 Aime12 problem number 7. Triangle ABC has side length AB equals 9, BC equals 5 times square root of 3, and AC equals 12. Point A equals P0. So it means this is the same. Here is A, also P0. P1, P2, then go on to P2450 equals B. It means B and P2450 is the same point. Are on segments AB with PK between PK minus 1 and PK plus 1, 4K equals 1 to forever 2449. So P1, P2, P3, blah, blah, blah. Then finally, yeah. And the points A also equals here, Q0, right? Q0, this is A. Q1, Q2, for so on, and Q2450 equals C. Here is C, the same this point. Are on segment AC with QK between QK minus 1 and QK plus 1, 4K equals 1, 2, 3 to 2449. So we can write like this one, right? P 2449, and here is Q 2449, yeah, and here is go on. Furthermore, each segment PKQK, like P1Q1, P2Q2, P3Q3, and like here P this, yeah, is parallel to BC. So this is parallel, all of them parallel to each other, then parallel. The segment cut the triangle ABC, right, into 2450. Yes, we have so many points, 2451 points, but the segment between them is only 2450. So 2450 area. And we have 2449 trapezoid and one small triangle, right? So, but each of these 2450 regions have the same area. The area of them is the same. Find the numbers of segments PKQK, I mean like P1, Q1, P2, Q2, P3, Q3, all of these segments. The number of segments of this one that have rational length. Rational length, it means the segment of the length of this PKQK will like equals P over Q, right? So that's rational length. P and Q are co-prime. So at the first glance, what idea we will got for this one? We saw this triangular and a lot of segments and parallel and area. So it's just talking about the relationship, the segment length, they are parallel, and the area ratio. So we exactly to think about the triangulars. For example, AP1Q1 similar to triangle ABC. So the area ratio equals the size ratio then squared, right? I mean, we will got for the area AP1Q1 if 1 to 2450, because we got so many area. That's the area ratio. It will equals to the side length ratio for this one is 5 square root of 2, then squared. And this is very good. Why? Because that included what we need to know, the length of P1, Q1, because it just want to know the length is a rational number. And this one include and the area relationship between them. So from this one, we will got which, yes, this is P1, Q1 squared. Then here is 75, right? Square of 5, square root of 3, square root of 3, 75. Then we crossing multiplication, we will get P1, Q1, each side times 75, right? 75 over 2, 450, square root of the, we know all of this is the multiple of 25, so we will get here is 3, and here is 98, square root of this one, 98. Of course, P1, Q1 is not a rational number because we can't get this, because we can write it like 3 over, and this is 2 times 7 squared, right? Okay, let's go ahead. We will try the second one. Want to find, how about the, what about for the P2Q2? P2Q2, and we will view this problem like, because we want to get the similar triangle, and then we can view this P2Q2 is the base of triangle A P2Q2, right? This is triangle. And now the area, this part area, include two small region. So is to the total one ABC is 2 over 2, 450. Then that's equals P2Q2 over 5 square root of 3. So this is important, this step, because otherwise if you think, oh, this one and how to calculate the area of this trapezoid, this side plus this times the height, and then times 1/2, oh yeah, this way will make the problem more and more complicated, right? So if we view the problem like this way, this thing will becomes easier. We can easily to get P2Q2, it will equals square. Now here is 2, and here is like 3 times 1, right? Now is 3 times 2, right? Because also here 75 times here, 2 times 75, and here is all of them cancelled by 25. So we will got 3 times 2 over 98, then times square root of this one. And also we know P2Q2 will not the rational length, but we find the pattern. I mean, we will got PKQK will equals square root of 3K over 98. I will write like this form, 2 times 7 squared. Okay, now the problem, it becomes very easy. Why? Because we want the PKOK to be the rational length, and we want this part is no problem, and we can write the K to the form like, it must be include a 2, because 2 over this 2 can cancel, and should over, and also include a 3, because 3, then 3 squared, here we got a 7 squared, then we can take off the square root, it will becomes the rational length, right? And then times a numbers, so there is a numbers square, right? It will times a numbers square. If we find, yeah, so how many segments will be rational length, it will depend on how many n can satisfy this K, and this K is greater than or equals 1, and less than and equals 2450, right? The last one, this one, will be 2450. So we will got here is 6n squared. Okay, we got 6n squared equals 2450 or less than or equal. Then we can easily to find n equals 20 because n squared, that's 20 squared, that's 400. 400 times 6 is 2400. And if n is 21, and n squared will be 441. 441 times 6 will greater than, right? 2400 plus 240 plus 6 is 2646, right? Yeah, this is greater than 2450, so we don't need this one, 21, so we know n is 20. That's the answer. So the final answer is 20. We're done. So this problem, the main idea, we just use a very simple knowledge that the ratio of the similar triangles, area of the similar triangles is equals the square of the sides ratio. Then another step important, just we don't need, we view this triangle and this, not just the triangle and the trapezoid. We knew a larger triangle, yeah. Then we can use this theorem again and again and again. We will find how to find the final answer, right? Hope you enjoy it. Thank you. I hope I can meet you for next problem.